Another essential concept in text processing is the use of n-grams. N-grams help us analyze not just individual words, but also the relationships between neighboring words. An n-gram is simply a sequence of n tokens. The value of n tells us how many words are grouped. When n equals 1, we have single words, called unigrams. When n equals 2, we have pairs of consecutive words, called bigrams. When n equals 3, we have sequences of 3 words called trigrams. For example, in the sentence, I love NLP, the unigrams are I, love, and NLP. The bigrams are I love and love NLP. The trigram is I love NLP. By working with n-grams, we can capture context that single words alone cannot. For instance, recognizing phrases like New York or credit card, which carry a different meaning together than the words do separately. To do this, we'll import 3 packages, NLTK, Pandas, and Matplotlib. You should already know that NLTK is the Natural Language Toolkit, which gives us functions for tokenization, stemming, lemmatization, and many other text processing tasks. Pandas is one of the most important Python libraries for data analysis. It's designed to make working with structured data fast and intuitive. The core feature in Pandas is the data frame, which works like a spreadsheet inside Python. A data frame stores data in rows and columns and makes it easy to filter, sort, group, or transform the data. This makes Pandas perfect for preparing text data for analysis, keeping it organized, and connecting it with other steps in our machine learning workflow. Finally, we'll use Matplotlib, which is the most common Python library for creating charts and visualizations. With Matplotlib, we can take the results of our text analysis and turn them into graphs, making it much easier to spot patterns and trends in the data. Okay, let's create some tokens for this example. These tokens have not yet been fully pre-processed. We'll cover that later in our next practical lesson. I'll copy our tokens over and then print them out to have a look at what we have. Now, we want to take our tokens and look at the unigrams that are present in this data. Remember, unigrams are single-word tokens. Examining them helps us understand the basic building blocks of our text, like which words appear and how often. This is often the first step in exploring text data because it provides a simple frequency count of individual words before we move on to bigger structures like bigrams or trigrams. To find the unigrams, we'll use both Pandas and NLTK together. We start with the nltk.ngrams function. This function takes 2 arguments, our list of tokens and the value of n. Since we want unigrams, we set n to 1. This gives us a list of all the one-word sequences in our text. Next, we wrap that result inside pandas.series. A pandas series is like a single column of data in a spreadsheet. It lets us organize our unigrams into a structured format that pandas can work with. Finally, we call value counts on the series. This goes through all the unigrams and counts how many times each one appears. When we print this out, we can see the most common unigrams. In this case, these are our most common tokens or words. For instance, the word to appeared 7 times, of 6 times, the 4 times, and so on. You can imagine how much cleaner this output would look once we finish pre-processing and remove the stop words. Looking at raw counts is useful, but visualizing the data makes it much easier to spot patterns, and it's also great for presentations. Let's take our top 10 unigrams and turn them into a chart. First, we sort the values using .sort_values, so the bars will be in order. Then we call .plot.bar with an H in the end, which creates a horizontal bar chart. Next, we can customize the chart to make it more straightforward. For example, we set the color to light salmon, adjust the bar width, and define the figure size so the chart is easy to read. Finally, we add labels and a title, the 10 most frequently occurring unigrams. When we run the code, the result is a clean horizontal bar chart showing our 10 most common unigrams. This is a powerful way to summarize text data and present it to others in a clear visual format. Okay, now let's move on to Bigrams. A bigram refers to the case where n equals 2. That is, we focus on the common occurrences of neighbouring word pairs that appear next to each other. It's the same piece of code. We just change n to 2 and rename the variable as bigrams. Here, we can see the bigrams that appear twice in our data. The rest appear only once, so we don't really need to plot this out, but of course we could also do that if we'd like. Finally, we can compute our trigrams. As you might expect, this refers to the case where n equals 3. In other words, we're examining sequences of 3 tokens that occur together. Here we see that these different trigrams only appear once. So again, we don't really need to plot this out. But when working with significantly larger datasets or data that has undergone more thorough pre-processing, this bigram and trigram analysis can give some exciting results. A quick note on terminology. We use the terms unigrams, bigrams, and trigrams for n equal to 1, 2, and 3. When n is any number greater than 3, we use the term n-grams to describe them. Now that we've covered this, let's jump into a practical example and put everything we've learned in this section together.